When we talk about the types of reactions, it ends up being a very nice shorthand discussing what we expect to happen in various kinds of reactions. And if you can categorize a reaction into one of these categories, it really helps you speed up the process of guessing what's going to happen, predicting what's going on with the energies, and thinking about some of the other tangential effects that are going to happen when you actually mix these together. Now, the first one I want to bring up is a precipitation reaction. And I'm sure you've seen one of these before. You mix two solutions together, and all of a sudden, some powder forms suspended in the solution. And because it looks kind of like it's raining or like snowing, that's where the word precipitation came from, more or less. It's coming out of what appears to be nothing to form something you can actually see. Now, at the microscale, what's really going on? In this solution, you've got a cation and an anion. In the other solution, you also have a cation and an anion. In both cases, we've got things that are dissolved and dissociated. When you mix them together, what ends up happening, though, is you can have the cations and the anions pair up to form a solid. The other two are probably going to stay dissolved and dissociated. And we'll talk about those in a couple of minutes in a different video. But the two that form together are going to create a tiny crystal of solid suspended in the eddy currents of the solution until they finally settle out. That's the precipitation that you're seeing. You're having aqueous turn into solid. The second category is going to be very similar. All the same things apply. It's just that now instead of creating a solid, you're creating small bubbles of a gas. Now, if you were to mix baking soda and vinegar, the baking soda has the carbonate ion. It's sodium carbonate. It's going to be dissolved in water, giving you sodium ion and carbonate ion. You'll have H plus from acetic acid and the acetate ion from acetic acid. Well, the H plus is going to pair up with the carbonate ion, and what's going to end up forming is some carbon dioxide, and there'll be a couple of other things left behind from that. We'll see those in a separate video, and also you'll find those in textbooks and things. If you're curious, you can always search for sodium bicarbonate, acetic acid, and you'll find the whole balanced chemical reaction for that. But either way, a gas is going to form. It starts out as very small bubbles. They find other bubbles, stick together, make larger and larger bubbles, and finally you can see them bubbling to the surface. But at the microscale, there can be tiny bubbles that are dissolved in the water that you don't even see. Now, the third category is one that you've heard of before for sure, acid-base reactions. And in an acid-base reaction, at least at the Gen Chem 1 level, you're going to have H plus and OH minus, and when they stick together, they form HOH, water. And so if you mix together exactly the same amount of acid and base molecules, you'll get salty water. Now wait a second, why did I say salty water? Don't forget, you can't have a bottle of H plus, you can't have a bottle of OH minus. All those minus charges are repelling each other. All the H plus charges are repelling each other. There's got to be some other ion in there to make it neutral, right? So H plus could be in the form of HCl, H plus and Cl minus. OH minus is probably going to be paired up with some Na plus, some sodium ion. NaCl is going to be what you form. Table salt. Whenever you mix together an acid and a base, you get water and a salt. And the salt's made up of whatever ions are left over after you make the water. Reduction and oxidation reactions. These ones are neat. In these, we're actually going to have electrons transferred from one place to another. That means that two or more atoms in your reaction are going to change their oxidation number. And we'll talk about oxidation number in a separate video as well. And the neat thing about that too, if you're passing electrons from one reaction to another, if you separate those two reactions and connect them with a wire so the electrons have to flow through that wire, you've just made a battery. And you can harness those electrons moving from one place to the other as a form of electricity. And if you have these reactions going to 100% completion, at least one of your reactants is going to be strong. They don't both have to be strong. If one is strong, it'll force the reaction to go to completion nearly all the time. If it's less than 100% complete, both of them are probably weak in the reaction. Both reactants are going to be weak. And we'll see examples of that in other videos.